One of the most powerful parts about prototyping today is that we're able to develop products much faster than any other point in time.
We help bring products to market. We're a full-scale product development firm. We cover everything from front-end user research to production support. To have both systems in-house gives us options. The FDM parts give us nice durable parts that we can go and actually start doing some physical testing with. The Polyjet parts are very high resolution, very good surface finish. So, depending on what the designers and engineers need at the time, we have that flexibility here in-house. This allows us to very quickly move through the development cycle. Having the machine here internally is probably 20 to 30% cheaper. The great thing about having the ability to make these parts so rapidly is we can go through 4 or 5 iterations in a day. We can come in the morning, parts are sitting on our desks, they can refine them, get another set printed in a couple of hours.
Today's revelations with being able to print a prototype overnight or even throughout an afternoon, we're able to develop something in a much more streamlined way, because in the past we had to machine a lot of these parts. So a good example of that is a medical device that we're developing. This device is taken from the technology of a life support product. What it does is deliver a drug to a patient. The amount of time it takes to develop a product is really reliant on collecting the user feedback as well as the ability to create the parts necessary for testing. So we need to be able to create parts that we can test that meet the same specs as production materials. So in this case, some of these components are printed parts. In this case, we're using the elastomer with PCB behind it to illuminate. Status LEDs are now able to function. The series of prototypes that we've developed have gone through a lot of changes. The first version of this product started much larger, and because of the ability to be able to print the parts quickly, we're able to optimize the size of the components and get the weight down as well. And that enabled us over the last few years to go from a 45-pound device when the client initially came to us and reduce that down to what you see in front of you, less than 5 pounds, and something that somebody could carry with them.
This is a UV curing wand, and this was the product that they've had on the market for many years. You can see it's pretty big, it's bulky.
So in this case, we go through a series of prototypes, and when we concept sketch, we then have foam models that we also create by hand.
And you can see there's a pretty wide range of different shapes and forms. But this was the first FDM that we went out with to really get feedback on, is this going to fit in people's hands? Is it function well? Are the buttons where they need to be? And get feedback on, are we on the right path?
But once it gets to a certain point, we need to make sure that it actually works the way that we expect. So we're able to print these components, install all of the hardware into it, and then test it with users and make sure that it fits within the hand sizes that we initially developed the product for.
We do a lot of prototyping early on because all these things need to fit together and work before we go and spend big dollars on tooling.
Sometimes you're pushing the limits as far as challenging the engineers to make the product smaller and demonstrating the need through prototyping why that's absolutely necessary.
So it took a number of iterations, and the only way we would have been able to get through this project so quickly is by having the tools to do that in-house. So with the FDM early on, and then the Polyjet later on, as we're refining the detailed features on this device. We don't like just making fancy sketches or theorizing about things. We like to actually see the products make it to the marketplace and be successful.